Hello F-sharp, and welcome back. Let's continue our introduction to the features of the F-sharp language. Today we're going to talk about a feature of F-sharp that I actually don't use very much. I use them extensively with collections, but I don't define my own, I don't create my own instances of them, and what I'm talking about is active patterns. Now, active patterns are still a little bit of a mystery to me. They are very powerful ways of matching and reshaping data, and I'm actually going to provide some links to some great talks by other people in the F-sharp community down in the description that you can follow up with. I just happen to work in domains that don't use them very much, but they are important to be aware of to have a complete understanding of the F-sharp language. So I'm going to show you how to define them because we want to understand the internals of them, and then in future videos, we will actively be using them, but we won't necessarily be defining them. So what is an active pattern? So an active pattern, there's a few different types of active patterns, and I'm only going to give you an introduction to the ones that I think are like truly necessary to understand to become proficient in F-sharp. And there is some more obscure features of them that I don't think are strictly necessary. And again, I don't think I've ever used them in real world code. So I will leave that to you. So the way we define them, and I'm going to define a very simple, kind of silly one, and it's going to be a file extension. File extension active pattern, and it is going to take a string. So what is going on? So the way we know we have an active pattern at this point is, I believe this is called banana brackets, the parentheses followed by the bar. So, and I'm going to put a space in between to just make it even more clear for you. But this is how you know you're looking at an active pattern in F-sharp. You have parentheses and then bars, and then inside of that is the kind of description of what your active pattern's name is. And this is a single case active pattern, and I am going to kind of show you how to define it and then use it, and then we'll go back and talk about how it's actually working. So I'm going to take the string, and I'm going to assume it's some kind of file path, and I want to get the extension off of it. So I'm going to say let extension equal system.io.path.file get extension S. So what this is going to do is going to return. So, okay, what is that? That seems kind of odd. And again, let's just go ahead and use it. So like my file, and let's say it's an Excel file. Now, how do I use this thing? Well, what I can do is say file extension ext equals X. Okay, there's a lot to unpack here right now, and I kind of needed to put everything out on the screen so I had things to actually point at to be able to describe for you. But again, this is our active pattern. This is the input to our active pattern. This is the logic of the active pattern. Here's the value that I'm going to send into that active pattern, and here's me using the active pattern. So what is going on here? Well, this is me actually using the active pattern. I'm saying, hey, I'm using the active pattern file extension. And what it is doing is it's taking this value on the right, putting it through the logic, and giving you the return value here. And so if I actually ran this code, I would get, and let's say, yeah, so print function, I'm just going to say, go ahead and print out what is the extension ext. And so it's saying that the extension is .xlsx. And so what this has done is it said, hey, you took X, which is this string, And then I applied this active pattern to it, and this is the result I got out. And now I'm using that result. Now, why on earth would I do something like this? That's a great question. The way I like to think about active patterns is they make it very easy to reshape data and put logic around your domain and simplifying domain representations. And I think a better example of this will actually be when I use an active pattern with more cases. This is a single case active pattern. Let's define one with more cases. So a classic one that people will do is even, odd. And it's going to take a value, which is an integer. And I'm going to say if v mod 2 is equal to 0, then even, else odd. So we now have this active pattern, which is taking an integer and checking whether it's an even case or an odd case. And now I have an active pattern with multiple cases. This was a single case. This has multiple cases. And I am basically saying here, this is the possible returns you're going to get from this active pattern. And now what I can do is I can have, say, my function, and it's going to take an integer. And I'm going to say, okay, now match v with, and this is where the power of the active pattern comes in. And so like, why would you do something like this? I agree. This is kind of odd. This is kind of strange. Well, what this is doing is say like, you know what? Even value, print function is even, odd, print function is odd. Okay, what is going on here? So this is where we're actually starting to utilize a little bit of the power of an active pattern. When we have this match with statement, we, instead of having like if thens, else's, elifs, we can do is say like, you know what, I'm going to embed that logic in an active pattern and say like, hey, this is how you actually can separate the values of a domain. So I'm going to essentially divide the values of the integer type into even and odd. These kind of even and odd domains is a way that I can separate them. And when I have this match with statement, it is applying this logic to whatever value I'm matching on. So this is me using the active pattern in a match with statement to say like, hey, this is how you can divide out those values. And so this is where the power of domain modeling comes in and saying, hey, for my domain, I want to be able to take in integers, but I then need to be able to separate those integers out into these kind of separate subdomains. I have the even integers and I have the odd integers. And so let's go ahead and actually use this. So I've now defined it, and now I can call my function and call it with a 1, and it's say, hey, is odd. I can put in a 2 and say like, hey, that is even. And so this is how I can encode the logic for how to separate the domain of integers. And if you're thinking about encoding business logic, what you could do is say like, hey, I have customers and I want to embed the logic for, hey, is this a customer type A or customer type B? And I'm going to put that in an active pattern. And let's actually do that. So like, okay, well, I have type, and then I'm going to have email, phone, or other. And I'm going to say, hey, contact. And this is going to be a string. And I'm going to say, hey, we want to separate whether this contact information is an email, a phone, or an other. And so the way we can do that is we're going to say, hey, if, and I'm going to use terrible logic here. So just forgive me right ahead. So contact contains Oh, no. Yeah, my apologies. This should be a let. This should be a let. Okay. Contact contains, and I'm going to say, hey, if this contains an @ symbol, then it's an email. And, oh, email. If contact contains, and yes, please forgive me. I know this is terrible logic. I'm trying to just give you an example. Else other. So let's say we have this incredibly simple domain. We're able to take these strings, and I want to be able to say that, hey, I have this kind of set of strings, and I want to separate them out into whether, like, hey, is this string, is this an email string? Is this a phone number string? Or is this some kind of other string that I don't know about? And so I'm embedding the logic around how I separate these values out into these different domains into an active pattern. And that's what makes active patterns really great, is it's a way of kind of encoding the logic of your domain. And then what we can do is we can say, like, hey, let my contact handler, and it's going to take the string. And instead of me having to rewrite this logic for, like, okay, what do I do if it's an email? Like, this is my email checking, my phone number checking. Instead of me having to rewrite this logic over and over again, I've defined it in one place, this active pattern. And now what I can do is I can say match C with email. And I can say, like, yeah, it's an email. Print function, and I'm just putting in stuff. It's an email. Or it is a phone. Print function, it's a phone number. Or it's other. And print function, other contact. And so the important thing, I think, where it adds like a lot of value when it comes to like domain-driven design, is that instead of having to repeat this logic over and over for how like one type maps into these different subcategories of that type, we can define that in one place using this active pattern, and then we can use it over and over again. And what's fantastic is, let's say, like, hey, our domain has gotten more complex. And let's say we have a new way of contacting somebody. And I know that pagers probably don't exist anymore, which is hilarious. And elif contact contains, I don't know. I'm just coming up with something stupid just to kind of illustrate it. Pager. But let's say for some reason, the way we encode things, if a string contains the substring chicken, it's actually a pager. I don't know. Okay, let's just say pager colon, something like that. And so again, I put all that logic for dividing my domain into a single place instead of spreading it out and redefining it in multiple places. And then I can reuse it. And then when I need to enhance my domain by adding additional cases, now what's happening is the compiler saying, like, hey, this is an incomplete pattern match on this expression, and say, like, hey, you're not handling one of the cases that is possible with this active pattern. So what it really wants you to do is come in here and say pager, print function, it's a pager here. Pager. So this is one of the really fantastic ways of utilizing active patterns, encoding the logic of your domain. Let's come back to this one, though. So this single case one, this file extension, this wasn't too terribly exciting. And yes, this is kind of odd. Like, why would you want to do something like this? Well, let me give you a better example and where you actually end up using it a lot more. So let's say we have files, and this is some list. And I'm going to say, yep. And I'm going to have my file. This is an XLSX, and then I have a few others here. I'm going to say this one's a TXT, and this is a CSV, and this is some tab thing, and I have no idea what that extension even is, and then pager, and again, another Excel. And let's say, hey, we want to iterate through each of these, but we only want the extension out of them. So one way you could encode this without using an active pattern, say, like, okay, well, for file in files do, let extension equal system.io.path get extension on the file, and then print function. And I'm just going to, hey, print out the extension. The extension is extension. So yeah, you could do that. And that's certainly valid. But if you're like, hey, you know what? I know I want the extension every single time, and I would rather not have to do this. Like, one thing that you could do is say like, okay, well, I could use this active pattern that I've defined up here, file extension, and I could do the following. Well, and let's go ahead and run this to actually prove that this thing actually is working. So, okay, yes, it has files, and we see it printing out the extensions. We have xlsx, txt, csv, tab, mmm. Okay, but let's say, hey, is there a cleaner way to do this? Yes, there is. So for file extension, extension in files do, and it's going to go ahead and bring that down. Okay, so what this is doing is it's saying like, hey, for each file in files, I'm going to go ahead and apply the active pattern file extension to extract the file extension of it so I can go ahead and work with it. And this is an example of where a active pattern can be used to reshape data or turn data into the form that you want it to. And this becomes really valuable when you want to iterate through key value collections, because let's just create a dictionary here real quick. So my dictionary, and I'm gonna say it's a dictionary. System.collections.generic dictionary. And I'm gonna just give it some values. So like 1, A, 2, B. But system.collection. The dictionary collection is expecting key value pairs. We have to do key value pair on this. Come on. Oh, okay. Fine. I'll open it. Open system.collections.generic, which means I can get rid of this. So, okay, I can take these values, and let's say I wanted to iterate through them, because a dictionary in .NET implements IEnumerable. So for X in my dictionary do, okay, well, what is X in this case? Well, X is a key value pair of integer and string. So I'm like, okay, well, I can do print function, key, and I have X, and say, give me the key out of there and value, and then I can get the value out of there. Now, again, this is perfectly fine, but it's kind of clunky. We know we want to work with the key and value anyway, so wouldn't there be a great way for us to reshape this data as we're doing this for loop? Fortunately, there is. Key value in my dictionary do. And I'm going to go ahead and copy this, change it to this. So this is an example of using an active pattern to reshape data. Each of the key value pairs coming out of dictionary runs through the key value active pattern, and that key value active pattern is separating those values out into a key and into a value for you to work with. So again, it's this kind of reshaping of data for you. Is it strictly necessary? No, but it makes things much cleaner. And where I think it's important is in cases like this, where you're trying to encode the logic of your domain. So there's another type of active pattern, because what we've been showing here is we have these single case active patterns. The key value is a single case active pattern, which takes a key value pair as its input. And then we have these, what are called total active patterns, where you have all the different possible cases represented in this active pattern. Like this can only be an even or an odd, or this can only be email, phone, pager, or other. There are also partial active patterns. And a partial active pattern is saying like, hey, something could possibly match this case or not. So example of like, and I'm going to go back to this even odd example and show you how to do it with partial active patterns. So in this case, I'm defining my active pattern. I'm going to say is even, and then I'm going to have this bar underscore. And what this indicates is that, hey, this is one possible value, but it does not necessarily represent the entire domain. There could be additional cases that are not covered by this. So vint, I'm going to say like, hey, this if v mod 2 is equal to 0, then sum v else none. And so what this is saying, like, hey, this is a partial active pattern. If I return a sum, then I fit this case. I am an even. If I return none, I'm over here. I'm in this, like, I'm something else. I'm not is even. I'm one of these other cases. So I don't know what I am. Then I could also say, hey, let is odd bar underscore v int. And again, I say like, hey, v mod 2 equals 0, then in this case it's a none because it would be odd in that case, else sum v. So now I have two partial active patterns, and can I use them together? Absolutely I can. So let my partial active pattern function. Again, I'm going to take this v integer and say, okay, well, I'm going to match v with, and now I'm going to say, hey, is even value. Print function is even. And I'm going to go ahead and have it print that value, even value. I need to zoom out here just a little, just to get a little bit more space. And then is odd value, print function is odd. And then I'm going to have this value, odd value. And what you're seeing now is that the compiler is saying like, well, this is an incomplete pattern match. Because what's different is that, hey, it could have been an even or it could have been something else. It could have been odd or it could have been something else. And so when I do these matches, at this point, the compiler doesn't know if I've actually covered all the cases because each of these active patterns are given the possibility there could be additional possibilities that I am not covering as an active pattern. So when we use this approach, we would end up having to say print function unknown. Now we know things about integers. We know that this covers both cases, but the compiler doesn't know. But what's different here is that like, hey, we're also actually returning values from these is even, is odd active patterns. So we can combine them together to create more sophisticated logic. So this is just the barest of introduction to these active patterns. And the way I like to think about it is it's the logic of structuring data. It's encoding the logic for how your types separate out into other types or how they can be reshaped into other types. And it plays very nicely with the match with statements in F# to ensure that you have complete domain representation and logic coverage. So I know that was probably a lot. This is a deep feature of F#. And there's a talk by Paul Blasucci, I think that's how you pronounce his last name, where he goes into much greater detail discussing active patterns and how to use them. I really just wanted to give you a quick introduction to them so you could recognize one when you see them and you have some idea of like how to use them. Because this one here, this kind of key value active pattern for decomposing the values coming from key value collections, I use this all the time. This is incredibly convenient. I have very rarely had to define my own active patterns, but that's more an indication of the types of problems that I work on, not necessarily whether it's like a valuable feature in F# or not. So very powerful tool, and I'm going to provide some additional resources for you to go and do some more research and figure out how to apply it to your domain. So thank you very much for spending some time with me. It's been really great. I hope you have a wonderful day. Bye-bye.